Ayan. So, once again, good afternoon to everyone. So, for today, we'll cover the following topic. So, in today's synchronous session, we'll have the following flow for our synchronous session. So, before anything else, since it's been quite some time since we had a proper lesson sa ating Chem 2, since matagal-tagal na rin since the last time that we actually met for our lessons in the synchronous session. So we'll start off with an icebreaker, followed by the lesson proper, and then finally, all other questions that you'd like to raise and other announcements as well. So with that, let me transfer to a different to a different screen. So to jog our minds so that we can be better able to really focus on the lesson for today, we'll start off with an icebreaker muna before we proceed to the lesson proper. So we have a very simple game lang naman for you guys. So this game is Guess the Food. So in here, I'll be showing you a picture or pictures. And your job now is to identify ano bang pangalan ng food na ito. So you can type your answer sa chat box or you can also raise your hand or unmute yourselves to answer. Okay? Sige, so let's have a sample na question muna before anything else. So guess the food for this one. So you have the letter R and this picture. Okay, so I see some answers coming in. So Vea, Sandra, Clarice, and a couple of others all said it is rice. So let's see ano bang tamang answer. So that's correct. So this one is definitely rice. So I guess you now have the hang of this particular na icebreaker na questions. Okay? So can we start now with the actual questions for the icebreaker? Okay, so paunahan to by the way. So we'll just try to check later on. So we'll just try to check as well your answers kung sino bang mauuna. And he or she will get a surprise later on in the school year. So with that, thank you for the confirmation. So, class, guess the food. So type in your answers now. Wrong spelling, wrong, Yisha. Okay. Sayang ano. Okay. Sayang, wrong spelling, wrong. So the correct answer is from Chelsea. That is carrot. Car and rat. So carrot. So congrats, Chelsea, for the correct answer for this one. So next up, let's have another question. So guess the food. Ayan, finally nauna na talaga si Isha. Okay. Sige. So a couple of people have the answers correct. So this one is mango. So good job everyone for getting the correct answer. So far we have Chelsea getting one and Yisha getting one as well. Now let's try to proceed to the next one. So once again, guess the food. Okay. Wow, ang bilis mag-type ni Isha ha. So, blueberry, according to Isha, Sophia, Chelsea, Vea, Adriel, Sandra, Jamir. So, let's see what the correct answer is for this one. So, this is blueberry. So, we now have 2 points for Isha. Okay. So, let us have a couple more. So, I think this is the last one. So, guess the food. Wow, sana all ang bilis-bilis mag-type. So, Yisha, Sophia, Clarice, Chelsea, Vea, Jamir. Let's check what your correct answer should be. It is cucumber. So, we now have 3 points for Yisha. Oops, okay. So, meron pa palang last. So, guess the food. Ayan. So, finally, we have a new entrant. So, Albert says potato. Same with Gwyneth, Clarice, Chelsea, Vea, Sandra. Give chance to others daw, sabi ni Yisha. Okay, so let's check what the correct answer is. So this is potato. Ayan. So we now have summary of our answers here. So we have 3 points for Yisha, we have 1 point for Albert, and also we have 1 point para kay Chelsea as well. So congrats to Yisha for getting the most number of points for this one. So in the next na mga synchronous classes natin, we'll still have more na mga tawag nito, icebreaker sessions. So again, you will now be able to receive a particular mystery prize at the end of the year. So stay tuned na lang, whatever it is. So once again, congrats to Yisha for getting that one. Okay. So I think we're now ready to proceed to our lesson for today. So let me open the PowerPoint ng ating lesson. So now that our minds are sufficiently already well prepared for our lesson, so let's try to talk about today's objectives. So for today, this lesson should be able to help you be able to explain the rate law or the rate equation, solve rate law problems in terms of concentration and time for a first order reaction, and number 3, to show accuracy and precision in your computations. So I think there's really a need to do more icebreakers since unfortunately this is a very computation heavy na topic. This one that we have today. So before we go into the actual topic, let's have a brief review muna. So in your Chem 1, in your grade 9, you might have already covered the concentration. Concentration, if you recall, it is a measure of the quantity of solute that is dissolved in a given quantity of solution. Now, there are many ways to express concentration. Some common ways to do this would be percent by mass, percent by volume, but the one that we're using for today is ang tinatawag na molarity. So if you have your solute A that's dissolved in your water, let's say, so the molarity of solute A in the solution is expressed as follows. So you represent it by a square bracket as shown here. So square bracket A, that tells you na you're dealing with the molar concentration. And the molar concentration of A is defined as the moles of A dissolved in solution for every 1 liter of solution. So the unit of molarity is the molar. Ang symbol ng molar is capital M, wherein 1 molar is equal to 1 mole per liter. Okay? So for this one, you might want to have your calculators at the ready so you can follow along with this discussion. So let's say we have the following example so that at least we can be refreshed regarding sa concept ng molarity. So let's say we have a 5-liter solution of 0.05 molar NaOH. The question now is, how many moles of hydroxide ions or OH minus ions are in the solution? So to do this, we just have to recall the definition ng molarity, which is this one. So copy ko na lang yan. So the concentration is given to be 0.05 molars. And this is equal to the number of moles of OH minus, let's call it as X, times all over rather the volume of the solution, which is 5 liters. So we can then easily solve for the number of moles of the hydroxide ions just by simple arithmetic. So let me just insert an equation over there. So we can now find the value of X by multiplying the concentration, that's 0.05 molar, times 5 liters. So sige nga, can you please compute for me how much will this be equal to? Don't forget the unit, Chelsea. We're talking about moles. So ang unit ng mole is mole. Okay, so Vea, we have Jameer, Chelsea, and Phil. Sandra as well. So all of their answers are similar. So I agree with you guys. So this one is 0.25 moles. So I know that this is moles because if you recall, ang molar, you can write this as instead mole per liter. And just by looking at the units here, you can see na itong liter na ito na nasa denominator, it will cancel out the liter that is in the numerator right over here. So this one cancels out. Oops. This liter, and you're only left with the moles na lamang. So that's basically how you express concentration in terms of molars. So what we're gonna do for us to be better able to really appreciate the first order reaction na tinatawag, so we have to look at a specific type of reaction. So in this case, we have a dye that we now try to react with the hydroxide ion. So let me start the the presentation for this. Ayan. So you have a particular dye which is called as crystal violet. So crystal violet, it has the following na chemical structure. So it's rather complex. It's a rather large molecule in here. And when you dissolve the crystal violet in your solution, so it gives you a violet color. So trivia, if I recall correctly, itong crystal violet, guys, it is the dye that's being used to stain the cell walls of our bacterial cells so that we can better see it through a microscope. So that is the basis of your staining, to be able to see your bacterial cells. So it has a violet color when it's dissolved in water. And now, this crystal violet, we will react it with the hydroxide ion as shown. So when they react, so these two now produce the following product. So this product, it is special because this one is colorless in solution. So just by simply looking at the color ng ating solution, we can then determine ang progress ng ating reaction. So as time goes by, we will see na ang color ng solution natin gets paler and paler since the crystal violet is being used up. So the chemical equation for this particular reaction is given below. Given na medyo complex ang chemical structure ng crystal violet, we'll just represent this one as Cv+. The plus charge here comes from the positive charge ng carbon right over here. And the product is CvOH. So this is all happening in aqueous solution. So what we can do, so we might be interested to determine now just how fast our reaction is going. So the speed or the rate of the reaction between crystal violet and hydroxide ion can then be expressed in terms of the rate of disappearance of either reactant. So balik tayo. Ang reactants natin were Cv+. So we can express the rate in terms of how fast our crystal violet is disappearing. And this gives us the expression over here. The one that I'm pointing with using the laser pointer. So take note of the negative sign. Negative sign ito because our crystal violet is getting depleted habang tumatagal. Ang crystal violet is being used up. That's why we put a negative sign in front of this one. So delta C concentration of Cv plus over delta T, or in other words, the final concentration ng crystal violet minus the initial concentration over the time that the reaction has occurred. So that's one way to express the rate of our reaction. Another way that we can measure the rate of reaction, instead of looking at the crystal violet, we might want to monitor instead the hydroxide ion naman. So if it's the hydroxide ion you're trying to monitor in this case, so we have the other expression here for the rate of disappearance of hydroxide ion. So the rate of disappearance of hydroxide ion is given by delta molar concentration of hydroxide over delta T. Again, take note of the negative sign. It is negative because ang hydroxide ion, nauubos siya as the reaction is progressing, so that the products are going to be formed. Now, another way that we can try to measure the rate of reaction, guys, is by trying to monitor how fast is the product appearing. So we now have yet another expression for the rate of reaction, R. So R here is equal to delta molar concentration of CvOH over delta T. So since our product is being formed, habang tumatagal, mas dumarami ang product na mayroon tayo. Which is why this right-hand expression here has a positive sign, since the delta of CvOH is increasing with time. Now, our R, or the rate of reaction, the unit of this one should be molar per second, or another way to write this would be mole per liter second. Okay? Sige, so with that, let's try to have the following na sample problem. So this problem is taken from our textbook by Silberberg. This is number 16.14 on page 729. So according to Silberberg, we are now asked to express the rate of reaction in terms of the change in concentration of each of the products and each of the reactants. And also, follow-up question, when the concentration of C is increasing at 2 moles per liter second, how fast is the concentration of A decreasing? So let me minimize this one so that I can type in the answers for this. So what we can do here, guys, is we have to look at the balanced chemical equation that we have. So if this is already balanced, we can now write an expression for our R. So the rate of reaction R, it is then equal to the following. So titingnan ko muna si reactant A. Reactant A, as you can see, has a coefficient of 2. So what I do here is, since reactant yan, this is going to have a negative sign. And ang coefficient ng ating A, which is 2, I put it here sa denominator. So that's why I now have negative 1/2. Again, the negative sign is because you're dealing with a reactant na nauubos with time. And that 1/2, it's because ang coefficient ng A is 2. So R here is equal to negative 1/2 times the change in the concentration of A. So that's delta concentration of A with respect to the time. Now we can also do something similar for our product B. So once again, titingnan lang natin ang balanced chemical equation here. Sa B, as you can see, ang coefficient niya is 1. So what I can do is, I could just write the following. Excuse me. So that's 1/1. The denominator 1, it's because B has a coefficient of 1. 1/1, as you know, it's just equal to 1. So there's no more need to write that one. And since you're dealing with a product sa B, so I don't have to write a negative sign anymore. So this should be positive delta concentration of B with respect to the time. So now you have the rate of appearance of the product B. So sige nga, at this point in time, so let me turn it over to you guys. So what I'd like you to do is, kindly please tell me, ano na ngayon ang rate of appearance of our product C? Base sa ating chemical equation right over here. So again, please feel free to type sa chat box, or you can unmute yourself so you can dictate to me what should be the answer for this one. So what is the rate of appearance or the rate of reaction in terms of C? So anybody who has an idea what the rate is in terms of C? So please type sa chat box or pwede rin i-unmute so you can dictate to me what I should write in here. So any guesses what should be written for this one? So hint, tingnan muna natin ang coefficient ni C. Ano bang coefficient niya? So we can answer this step by step. Okay, so coefficient ng C is 1. And since product ito, so dapat this should be positive in sign. So positive 1 over 1. And since itong 1 na ito, by the way, galing siya sa coefficient ni C. But since 1 over 1 is still equal to 1, so actually there's no more need to write this one. So now I have to type the following. So on the numerator, can you tell me what I should type in here? Pwede spell out lang if you don't have the delta symbol on your computer or available. Okay, so Chelsea says I should write there delta C. So that's correct. It should be the change in the concentration of our product C. All over, so what should I type here sa denominator? Anybody who has an idea? Anong ilalagay sa denominator? Okay, so Chelsea, we have Yisha as well. So both say na this should be delta T. So that is correct. So in this one, we now have the different na expressions for the rate of reaction. Base sa A, we have this first expression. Based on the concentration of B, we have this one. And based on the concentration of C, we have this one as well. Again, please take note of the signs. Negative ang expression pag reactant, tulad ni A. And pag product yan, this one should have a positive sign. So now we have answered the first part ng ating question, expressing the rate in terms of the change in concentration. Now the second question is, when C is increasing at 2 moles per liter second, how fast is A decreasing? So what we can do here is, copy ko na lang ito. Si B, parang hindi siya gimension sa second part ng question. So let me remove that one. And what it says in here is that ang C natin, it is increasing at 2 moles per liter second. So actually, it turns out, itong 2 moles per liter second na ito, if we read the problem carefully, that is actually the value of the change in C with respect to time. So that's 2 moles per liter second. So what I can do now is I can actually substitute the given value of delta C over delta T in the equation. So this is 2 moles per liter second. And I can now compute ano ba ang change in the concentration of A. Okay, nasaan ang dot? Ayun. So what I can do, I can now multiply both sides of this expression here by 2. Oops, sorry. So multiplying both sides by -2. So we are now left with only the change in A with respect to time. So can you please compute for me how much na ang value ngayon ng change in A with respect to time? Please don't forget the unit. Same dapat siya ng unit as the delta C over delta T. Oops. Okay, so the correct answer here should be the 2 moles per liter second times -2 sa labas ng parenthesis. This gives me -4 mole per liter second. So that is how fast my reactant A is decreasing. So that is how we can now relate the speed at which our C is increasing with the speed at which our A is disappearing in our reaction. Just by using the rate of reaction na expression that we have right over here. So with our number 16.14, na-follow lang ba how we were able to solve this one? Or are there any questions on how to do this? Okay. Sige, so let me try to test you with this one as well. So let's say we have the following na reaction na naman. Let's say we're given the following balanced chemical equation. As shown in here, let me type it in sa screen. And you're now asked to be able to write the rate of reaction in terms of the products and the reactants. And same pa rin ang values. So when our C is increasing at 2 moles per liter second, so how fast is our A decreasing? So what I'd like you to do now is, first, focus muna tayo kay A. So what should I write in here? So meron na tayong delta A over delta T. So ano na lang bang kulang dito? para makompleto ko ang expression for the rate of disappearance of A. Okay, so Vince says negative sign. Same with Chelsea. So that's correct. But why is it correct? So can you please explain, Vince or Chelsea, bakit negative sign dapat ito? Okay, so Chelsea says because our A is disappearing since reactant siya. So that is correct. So that is for our A. So let me try for letter B na naman ngayon. So for our chemical species B, so I can now type the following. So can you please tell me now sa chat box, ano bang kailangan para makomplete ko ang rate of disappearance of B? So again, please base it on the balanced chemical equation na nasa taas. Okay, so I still have the same people answering. So let's check later on what the answer is. So anybody else who has a different answer? So what else do I need to type in here to write the rate of disappearance of B? Ano na lang bang kulang dito? So I have the rate of disappearance. Or the reaction rate rather. So do we agree ba with Vince and Chelsea for this one? Okay, so Sandra agrees. So I tend to agree as well. For me to complete the rate of reaction in terms of our B, I have to type here negative 1/3. And finally, we can still express the rate of reaction, this time in terms of our C. So copy ko na lang ito to save me the effort in typing. So what should I type? What else should I type in here to make the expression complete? Okay, so Chelsea, we have Phil, we have Sandra, we have Isha, Vince, Julia as well. All of them saying na this should be positive 1/2. So that is correct. So Jamir also says 1/2 siya. So can I ask any volunteer to tell me why should I type 1/2 in here? Saan ba galing itong 1/2 na ito? So anybody who can explain for us why we need to type 1/2 in here? Okay, so Chelsea says it's because the coefficient of C is 2. So that's correct. So again, magbabase lang tayo sa coefficient in the balanced chemical equation. So that's why we have the following. Now to answer the second part ng question, so when C is increasing at 2 moles per liter second, how fast is A decreasing? So for this one, again, we have to input our value for the delta C over delta T, which is 2 moles per liter second. So based on my equation here, I have delta A, negative delta A over delta T is equal to 1/2 the delta C over delta T. And for this one, it turns out, itong delta C over delta T, ang sabi sa problem, so C is increasing at 2 mole per liter second. So therefore, this one, I can replace it by 2 moles per liter second. So can you please compute for me? So ano bang value ng ating delta A over delta T? Oops. Okay, so Sandra has her answer. Anybody else with an answer for delta A over delta T? So we have Phil, we have Chelsea as well. So they all agree that this one is negative 1 mole per liter second. So what this means to say is, ang ating C, when it is appearing at 2 moles per liter second, ang A natin nababawasan at a rate of 1 mole per liter second. So that is how we can now compute how fast our reactants and products are being changed in the reaction. Okay? So I hope that helps clear out some of our questions for this one. Unless there's anything you'd like me to go over again for the two sample problems we have. Okay, so kung wala na, let me start the presentation again. Since this one is animated. So now we go back into our crystal violet and the hydroxide that we allow to react. So what we can do, we can now try to react the two together inside a container which we call as a cuvette. Ang cuvette has the shape of this one. So as you can see, it's made of a plastic material. For more expensive cuvettes, they are made up of quartz or some other hard na crystalline substance. And in here, we can now mix our crystal violet and hydroxide together. So you can see the initial concentration of crystal violet. That's 1.5 times 10 to the power of negative 6 molar. While for NaOH, we have the initial concentration of 0.05 molar. We can then try to be able to compare this one to another cuvette na naman. This time, in the second cuvette, ang concentration ng NaOH is twice the first one. So you might notice ang crystal violet stays the same while NaOH is already multiplied by 2. We can then start the timer and then we can observe now the change in the color of the solution by using a special na machinery called the spectrophotometer. Spelling niya is, I'm typing it here sa ating chat box. So purpose ng spectrophotometer is it relates the color of the solution with its concentration. So if ever we're going to have a face-to-face session, so you might be able to use the spectrophotometer sa ating chemistry laboratory sa campus. Okay, so now we have the two solutions. So they are now mixed together. Let's now start the timer and see what happens. Okay, animated GIF siya, so it's repeating. You might notice at 7 seconds, itong ating right na cuvette, it's a little paler compared to the left cuvette. So it is something that we expected from our discussion in the previous lessons. Since ang concentration ng NaOH dito is greater than the one over here, this one should proceed at a faster rate. So mas mabilis niyang nauubos si crystal violet. Compared to this one, where the concentration of NaOH is not so great, so crystal violet does not disappear as fast. So let it go one more time. So ayan. So you might be able to see the difference in the color for this one. So basing on this experiment, we can now see that ang ating reaction rate, R, is directly proportional to the concentration of the OH minus. As we see, when the concentration of OH minus is doubled, ang rate ng ating reaction also doubles as well. So kita mo naman, base dito, at 7 minutes, you have a color of the first cuvette equal to the color of the second cuvette only at 3 minutes and 30 seconds. Ang difference ng dalawa is, ang concentration nito is 1/2 of the concentration ng ating second one. So if you want to be a little more mathematical about it, so we can express the rate in cuvette 1 as the following. So just by looking at the concentration of the crystal violet, since the crystal violet naman ang may color, so rate is given by this expression. for the first cuvette, while for the second cuvette, you now have the following. So this is over 210 seconds. 3 minutes 30 seconds is 210 seconds. But if you observe carefully, this one can be expressed in terms of R1. So we can see a relationship between the two rates of reaction. Now we can do a similar thing na naman. So instead of a spectrophotometer, we can then now use a different way by which we can now monitor ang concentration ni OH-. And then, ang babaguhin natin instead is ang concentration ng crystal violet sa kada cuvette. So we can also see, by doing that same experiment, na sa crystal violet na ng bago, instead of NaOH, that the rate is also proportional to the concentration of the crystal violet. So this allows us to have yet another expression for the rate of reaction. So here is where what we call as the rate law comes in. So the rate law is defined as a mathematical equation that relates the rate of a reaction to the concentrations of the reactants. So in the example ng crystal violet and hydroxide ion, we now have the following. So we have R here is equal to K. K is the rate constant times the concentration of the crystal violet raised to the power of X times the concentration of hydroxide raised to the power of Y. X and Y, so these are very specific values which we need to determine by experiment. So X in particular, it is called as the order of the reaction with respect to the crystal violet. And Y, in this example, is the order of the reaction with respect to the hydroxide. So kung isumatotal mo ang X and the Y together, we now get the overall order of the reaction. So if let's say we have X here, kunwari lang, X is equal to 1 and Y is equal to 1. So 1 plus 1 gives us an overall order which is equal to 2. So that's how you find the overall order. So X and Y is something we need to determine by experimentation. So what we can do, we can treat it in a more general manner. So let's say we have any reactant A. So what we can do, again, we can just collect data for this one. We can try to measure the concentration of reactant A at any given time, and then we can now try to plot the graph for that one. So we can have the following 3 cases. So if you have the reactant A na concentration, you plot it in the y-axis, and the time plotted on the x-axis. And if you notice na, you end up with a straight line, as you can see in here, you now have what is called as a zero-order reaction. Zero-order siya na tinatawag because in here, the rate law niya is given as follows at the bottom. So the concentration of A is raised to 0, or we can express this one as K na lamang. Since if you recall in math, any number raised to 0 is equal to 1. So K times 1 gives us K na lamang. Now let's say you try to do the graph. So meron kang graph ng concentration sa y-axis versus time sa x-axis, and nakita mo na hindi siya straight line. So what you can do, you can make a second graph na naman. This time, in the second graph, you try to take the natural logarithm of concentration and ang time remains as it is. In the second graph, if you now have a graph here that is a straight line, you now conclude na what you have here is a first order reaction. First order siya because looking at the rate law here sa baba, ang exponent ng A is 1. Now let's say you did this one. You made the second graph, ln of A ang sa y-axis, ang time is nasa x-axis, and still hindi pa rin siya straight line. So finally, you can still now make a third graph, where in the third graph, you have the reciprocal of the concentration ni A at any given time sa y-axis, at ang time is nasa x-axis pa rin. Now, in your third graph, if you now are able to produce a straight line, as you can see here, you now conclude na what you have is a second order reaction. In the second order reaction, ang rate law is as follows. Notice, ang concentration ni A is raised to the power of 2 pag second order. So, zero order, A is raised to 0. First order, A is raised to 1. Second order is raised to 2. And how you determine anong order niya? You have to do this one by graphing. So you have to make these three graphs as shown in here. So whichever graph gives you a straight line, that enables you to determine ano bang order ng ating reaction. So for us to better understand how to determine the order of reaction, let's say we now have the following. So you have this sample problem. So this one is adapted from our textbook by Silverberg. In this example, the compound AX2 decomposes according to the equation below. So you have this equation as shown, and using the data that we gathered by experiment over here sa left side, so we are now asked to answer the following. First, we have to write the rate law of this reaction, and letter B, what is the overall order of the reaction? So for me to be able to enter my answers for letters A and B, once again, let me stop the presentation muna and skip to the editable na PowerPoint. So for me to write the rate law of this reaction, what I need to do is, I now write the following. So the rate law, it's equal to R, equal to the rate constant K, times the concentration of ang ating reactant. Ang ating reactant nag-iisa lamang, so this is AX2. So that's A, X2 as the only reactant. And this one, this is now raised to an exponent, which we now determine using the data that we have collected. So let's say the exponent here is X. Since we have to find that one out using the data. So you might be wondering, sir, how about this AX na gas and the X2 na gas? Are they not supposed to be included sa rate law? So the answer here is, we don't include them. Sa rate law, ang isusulat lang natin is the reactants that we have. So since AX2 lamang ang reactant natin, so that is why we have to write AX2 over here. Now, another question you might be having at this point in time is, Sir, how about the coefficient of AX2? So is it included at all? So the answer here is no. What we need to write here is ang concentration lamang ng reactant natin. Whatever is the stoichiometric coefficient, so it does not appear at all sa ating rate law na equation. So we're only interested in the reactant, its concentration, times the rate constant K, and kung ano ba ang value ng X na ito. And this X, we need to determine it by using our data that we have in here. Now, you might recall last week, we were able to discuss how to use our Excel to be able to make our trend line, our scatter plots, and the trend line. So we'll be using that one here again to be able to determine the answer sa ating letter B. So in here, I've already typed out ang ating data na nasa PowerPoint. So again, if you forgot how to make the scatter plot, isa-select ko lang data na ito that we have, type in here, click on the Insert tab, select the scatter chart, and we have this one. Okay, please don't hang. Ayan. So in here, just by looking at this one, I can see right away na parang hindi pa siya straight line, kumbaga. So maybe we still need to be able to do some more graphs for this one. So what I'm going to do, so I don't get confused kung which graph is which, let me double-click the chart title para palitan ko siya. And for the chart title, let me type in here molar concentration of AX2 as a function of T. So AX2, in case you're wondering, it is on the y-axis, and our time, it is found on the x-axis over here. So just by looking, we can confirm na parang hindi pa siya straight line. But if you want to be really sure, we can select the data, right-click, add trend line, and then go to formatting to see ano bang value ng R squared for this one. So as you can see, ang R squared is 0.9195. That indicates to me na hindi talaga siya straight line at all. So what I do, let me just set this one aside for now. What I can do is, I can now try to find the natural logarithm of AX2. To do this, I type the equal sign, ln of itong concentration na ito, which is 0.05, and I now have the following. Continue on typing the same, or pwede rin naman, i-select ko ang lower right corner na ating cell, drag down, para makopy ang formula na i-type ko, and so I now have the ln of the concentration at all times. So this allows me to make now my second graph. So for my second graph, what I need to do is, again, isa-select ko pa rin sa time, and press the control button, press and hold the control button, select the ln of AX2. So this time, I've already selected this one. Ito na siya ngayon ang mag-a-appear sa y-axis natin. So once more, we make our scatter plot. And we can see now that it's a little bit better compared to the first graph that we have. Again, so that we don't get confused as to what graph is which, so let's label the chart properly. Double-click the chart title and replace it by ln AX2 as a function of time t. And for us to really have a measure of how straight our line is, again, we select any data point that we have here by left-clicking it, then right-click, add trend line, then lalabas ito sa right side ng ating screen, and we now display the R-squared value. And para kompleto, let me also select as well the display equation on chart. So this is now what I have. So comparing the first graph that I have, this one is R-squared equal to 0.9195. The second graph, on the other hand, has an R-squared of 0.9986. Since itong R-squared na ito is closer to 1, I then say na this one, the second graph, gives me a straighter na line compared to the first. And finally, for completeness purpose na lang, let me also compute the reciprocal of AX2 rin. So to do this one, so let me type the equal sign 1 over ang concentration at time 0. So pressing the equal button, I get this one. Again, select the data, hover the cursor above the lower right portion ng ating cell, and drag down to copy the formula. I now have the following. And to make my third graph, again, isa-select ko lang ang time and the reciprocal of concentration right over here. To select these two, what you need to do is, after ma-select si time, press and hold the control button, click, and select the 1 over AX2 na column. So that way, I have already selected my data. And once more, I make my scatter plot as shown. My screen is really small, so it can't accommodate everything. Tabunan ko na lang itong first na graph. Ayan. And so that I don't get confused, please make it a habit to change your chart title and label this one appropriately. So this is the reciprocal of the concentration of AX2 as a function of time. And for me to have a way to compare the straightness of the data, once again, I select the data in here, right-click, add trend line, and then I now try to look at the R-squared value for this one. So in my third graph, so it's a little bit better than the first. 9195 ang first. This one, ang third graph natin is 9395. but it's not as good as my second graph. So basing on the three graphs that I made here, using Microsoft Excel, I'm now able to make the following conclusion. So in here, what I can then conclude is that ang x natin is equal to 1. Since pag x is equal to 1, you have a first order reaction. And based on the PowerPoint we had earlier, pag first order reaction, that is when you have a straight line pag ln of A as a function of time. Or another way to write this would be the following. So therefore, the rate law of this one is simply R is equal to K times the concentration of AX2. Now, for the overall order of the reaction, since nag-iisa lang naman siya na product na mayroon tayo, so the overall order, ibabasa lang natin sa exponent ng AX2. So from the rate law that I have, the overall order is equal to 1. If mayroon ka pang other na reactant dito, included in the rate law, then you have to add the two exponents to get the overall order. But since ito lang naman mayroon, so therefore we conclude that the overall order is then equal to 1. So that's how you determine the rate law and the order of the reaction using Microsoft Excel. So at this point, let me go back to the Microsoft Excel muna. So are there any questions ba on how to make the three graphs that we have in here sa screen? Okay, so Chelsea, good question. So Chelsea asks, Sir, paano po ulit nakuha ang values for ln? So how to get the ln? Erase ko na lang ito. So to do this one, I just type equal sign ln open parenthesis, iselect ko ang concentration at time 0. Pressing enter, I now get my value. Again, at time equals to 2 seconds, I can do the same. So equal button, ln, open parenthesis, ang concentration at time 2 seconds, and so on. So ln open parenthesis equal to, and the concentration rather at time 6 seconds. Press enter, I have the following. And so on so forth until I completed all of the ln values. Or pwede naman, kung nagmamadali ka, just drag your cursor in here sa ating side ng ating cell and then drag down para makopy ang formula. So that is how I get my ln values. So for this one, same pa rin. So again, let me just delete na lang to better illustrate how to do this one. Again, equal button, 1 over, ano bang concentration niya at time 0? So click ko lang itong cell na ito. Same for time 2 seconds. And so on. Until ma-compute ko ang reciprocal ng concentration at each time. So I think Chelsea already got it. So na-follow lang ba how to compute ln and the reciprocal using Excel? Okay. By the way, you might be wondering, sir, saan nga galing ito? You might already be quite lost since it's a little bit technical. Galing to siya sa ating problem, guys, ha? I just copied it. I just typed it beforehand para lang at least mabilis sa tayo na makagamit ng Excel. So, ayan siya. It is coming from the sample problem. Okay? So, any other questions you'd like to raise on how to make the 3 graphs in here that we have? Okay, so Chelsea says none. Can I hear from the others in the class? So any questions on how to make the graphs that we have here? Okay. So again, let me emphasize. So make it a habit to always change the chart title para lang you don't be confused with ano bang chart ang nag-correspond to which. So just change it. And paggawa ng trend line, also please try to show ano bang value ng R squared. If ang R squared natin, guys, is close to 1, or rather, whichever R squared is the closest to 1 out of the 3, that tells us ano bang order ng reaction. So itong first graph na ginawa ko, pang zero order ito, malayo ang kanyang R squared to 1. So definitely hindi siya zero order. Itong second graph, malapit na siya sa 1. So therefore, that's why I concluded na this one is a first order reaction. And just to verify, itong third graph, pang second order reaction ito, since the R squared is already far from 1, I therefore conclude na definitely hindi siya pang second order. That's why I was able to come up with the answer right here for letters A and B. So pag first order, ang exponent ng reactant is 1. And overall order, isumatotal ko lang ang exponent ng lahat ng reactants. Mayroon tayo sa rate law. So I hope that one is clear to you guys. For this one. Okay. Sige, now moving on. So maybe later you can also ask other questions that you might have. So we now try to bring together ang dalawang ways that we can express our reaction rate. At the very beginning, we express the reaction rate just by looking at the rate of disappearance ni reactant A as follows. And using the rate law, we are also able to come up with this expression right over here. So what you can do, so if you have your calculus already, what you can now do is we can now try to solve for the concentration of A at any given time. So it's nice to know ano ba ang rate, but definitely, if we're handling chemicals or if we're trying to use them in an industrial setting ba or in a research setting, we're more interested to find out ano bang concentration niya at any given time? So using calculus, we'll just skip it over, pang math na iyan. We don't need to make our lives any more difficult than it already is. So I leave it to your math to explain how we get this one. Using calculus, we now arrive at this equation right over here. So this one, the one that I have in bold, ito siya tinatawag na integrated rate law expression for the first order reaction. So in this integrated rate law expression, we have the following. Ln concentration of A, T, this represents the natural logarithm of our A, concentration, at any given time. Wala ito na edit. Whereas this one, ln A sub 0, this represents the natural logarithm ng initial concentration ng A, or in other words, ano bang concentration niya at the very beginning of the reaction? And our K here is our rate constant pa rin. Pag first order reaction, guys, take note, ang rate constant has the unit of 1 per second. Now, you might be wondering, sir, itong K, ano bang difference niya from our R? So, how are these two different? So, our R, so to clarify it to you, our R tells us the how fast or how slow the reaction is. This is the actual rate of the reaction. Ang K natin, on the other hand, this is a proportionality constant that allows us to relate ang value ng R sa value ng concentration at any given time. So without the K, we cannot relate R to our A over here. So take note of the difference between the two. Also, ang K, ang kanyang unit for first order reaction is this one, while our R, ang unit niya is molar per second. So please take note of the difference. Now, if we look closer at the equation ng integrated rate law, so we can also find the following na pattern. So on the left side ng ating equation here, so we can actually express this as the variable y. So it corresponds here to the y-axis of our graph. Our time t is the variable x. So kita naman natin sa ating graph here, ang time is nasa x-axis. While our negative k, this represents the slope of the straight line that we have. And finally, the b, or the y-intercept, this is represented by ln a sub 0. So ln a sub 0, this is the point at which the straight line touches our y-axis. So that's how we can relate the graph that we have to the integrated rate law right over here. Okay. So also, let me go back muna into the presentation for this one. So since this one is animated, So the integrated rate law expression allows us to determine an important quantity, which is called the half-life. So in chemical reactions, ang half-life, this is the time that is needed for one half of the original concentration to be consumed entirely ng ating reactant. So using the, tawag nito, our integrated rate law expression, we can then derive the expression to find the half-life T sub 1 half, and we find that pag first order reaction iyan, ang half-life natin is only dependent on the rate constant alone. So half-life is equal to 0.693 over the rate constant that we have. So that's how we determine ano ba ang time needed for one half of the original reactant to disappear completely as it is being turned into the product. So balik tayo sa problem na ito. So we have already determined earlier ang ating order for this reaction. We also have determined the rate law expression as well. This time, we're now asked to determine the half-life of the reaction. Next, estimate the concentration of the reactant after 90 seconds. And finally, determine at what time is the concentration down to 0.005 molar. So to do this one, let me go back into my Excel that I've already prepared earlier. So this time, since alam naman natin na first order reaction siya, tanggalin ko na lang itong zero order na graph and itong second order na graph. Let's just focus on the first order graph that we have over here. So this time, ang titingnan natin is ang equation ng trendline natin. So what I have here is, let me type it out, y is equal to negative 0.0884 times x minus 2.9725. Now, base sa ating equation here for the integrated rate law, itong y na variable natin, this actually represents the ln of A at any given time. Our slope M is represented by the K, and the B is the ln A sub 0. So therefore, for this one, I can now make the integrated rate law expression base sa ating equation of the trend line over here. So I have ln of the AX2 at any given time is then equal to, ang K natin, so it turns out ang K natin is equal to this one, negative 0.0884. So what we can do is we can just take out the negative sign. Tingnan lang natin ang value ng slope in here. Y. Nah. Ang x natin is our time at any given point plus ito siya, ang ating value na ito. This is our ln concentration of AX2 at the very beginning ng reaction natin. So basing on the trend line that we have here, I can then conclude na my negative K is equal to negative 0.0884. Or multiplying both sides by negative 1, I can then write K is equal to 0.0884 per second. Ang unit ng K, please remember, sabi dito, K is having a unit of per second. So this allows me to be able to answer now yung ating half-life for this reaction. So balik tayo sa ating PowerPoint. So to find the half-life of this reaction, it's very simple. All I need to do is, I just have to substitute the expression right over here. So half-life is equal to 0.693 over K, wherein ang K natin, based on my trend line that I made, it's equal to 693. My K, going back into the equation that we have, it's equal to 0.0884 per second. So I can express per second as follows. So using my calculator, I can then compute how much this is. So 0.693 divided by 0.0884. So my half-life is therefore 7.84 seconds. Again, let's always box our final answer for this one. So that's how you find the half-life. So all you need to do, just look at your trend line. Ang slope niya, the value of the slope is our K, and that allows us to compute the half-life as follows. For letter B, to estimate the concentration after 90 seconds, all we need to do is plug in the values sa ating integrated rate law expression right over here. So the integrated rate law expression is this one. So ln AX2 after 90 seconds is equal to the K. So K here is equal to 0.0884 per second. times the time, which is 90 seconds, plus ln of the original concentration ng AX2. So this one, base sa ating data, at time 0, ang concentration niya is 0.05. 0.05 molar. Okay, so using my calculator, I can then compute for this one. So simplifying the right side, I now get the following. So ln of the concentration after 90 seconds is equal to the following. So negative 0.0884 times 90 seconds plus ln of at time 0, again, ang concentration is 0.05. And this is equal to negative 10.95. Okay? But this is not yet the end. Ang ating concentration, as you can see, nakapaloob siya inside the ln. So what you need to do is, you just have to get the value in here, na negative 10.95, and then what I do here is the following. Okay, we're almost done with the time. I wasn't able to keep track of the time properly. So what I need to do is, I just type in my calculator. Okay, so hanapin nila sa calculator nyo, itong meron ditong E, tapos may box sa taas. So E raised to negative 10.95. If you can't to find this one in your calculator, you can always use Excel to do this. So to compute anong value nito, let me just type it in here very quickly sa Excel. E raised to negative 10.95, I can compute it as follows. So equal button, EXP, negative 10.95. And this is now my value. So that's 1.76 times 10 raised to the power of negative 5. Itong capital E, this is 10 raised to power of negative 5. So that's 1.76 times 10 raised to the power of negative 5. Ang ibig sabihin lang nitong E na ito, E raised to E negative 5, like this, guys, by the way, it's the same as writing 10 raised to the power of, times rather, 10 raised to power of negative 5. So they just mean the same thing. And don't forget the unit of the concentration. So this should be in molar. So that is how you answer. That is rather how you use the integrated rate law expression to find the concentration at any given time. Okay? So we're already a little bit overtime for this one. So what I'll do, I'll just send you a video showing you how to solve this one. But at this point, let me hear from you guys one last time. So any questions ba? How we answered letters A and B before we end the session? Okay, thank you. Sige. So, again, please just check K-Hub for the solution ng letter C. So, in the meantime, so I'd like to thank you for your active participation for today. So please be sure to answer the attendance for this session. So with that, thank you so much. So may you have a great week ahead of you. And until next time.
Thank you po, sir. Bye
Thank
po,
you po,
sir.
sir. Bye po.
Bye everyone. Sorry
Thank you
na
po, sir.
overtime
Bye.
tayo.